Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
Yeah, you give me an example of a rational number and an irrational number.
Yeah, the rational number is 2.
Good. A rational number is 2.
And irrational number is something like 10/3.
10/3 is rational. Well, irrational, I'm happy that I'm even remembering this. Irrational numbers are numbers that cannot be expressed as a real fraction. Let me explain. Let me write it down first, because in this test you will also be hearing about irrational numbers, rational numbers. Where rational numbers can be expressed as real fractions. Let me write it down first. Rational numbers can be expressed as real fractions. You just mentioned 2, so I will use that 2. Example 2. 2 is the same thing as 2/1, so it's a real fraction. Even though it doesn't make sense to write 2/1, but it's a real fraction. We will call this improper fraction, isn't it?
Yes.
Okay. Any number that can be expressed as a real fraction is a rational number. Like 2/1, like 3/4, like 10/3. You gave an example, 10/3. 10/3 is a rational number because it's a real fraction. Or 1/3, or 2/3, or 1/5, or 5/4, or 5. Any number that can be expressed as a real fraction is a rational number. But if it cannot be expressed as a real fraction, it's irrational. If you press an irrational number in a calculator, the decimal will keep going, no ending. But since your calculator doesn't have an infinite space, it will just stop somewhere. An example, let me first of all define irrational number. Irrational numbers do not have real fractions. Irrational numbers cannot be expressed as real fractions. And I go to the next page. Let me give examples. An example is root 2, pi, etc. Or root 3. They are all irrational numbers because they can be expressed as real fractions. Or root 5. Or even root 6. Square root of numbers that are not perfect squares are irrational numbers. Is root 4 a rational number? Or irrational?
Yeah.
Root 4 gives what? 2. So root 4 is rational. How about root 6? Is root 6 rational or irrational?
Irrational.
Root 6 is irrational. Root 4 is rational because root 4 gives 2, and 2 is the same thing as 2/1. The answer can be expressed as a real fraction. But root 2, you can't express it as a real fraction. If you press the calculator, you have numbers which keeps, you have decimals that have no end. You know, sometimes we express pi as 3.14. That's just an approximation. In fact, pi continues. It can be 3.142 something, 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 something. It just keeps going. But we just stop because of lack of space. 3.14 dot, 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 dot. So it's irrational. Okay, so when we are working with irrational numbers, that's when we talk about surd. Surd is usually with operations with irrational numbers, especially in root form, whether square root, cube root, and what have you. Okay, so let's start with addition and subtraction of surd. I'm still on this same page. Addition and subtraction of surd. Addition and subtraction of surds. When you are treating surd, just remember your algebra. Treat surds as algebra like you will treat x or y. For instance, root 3 plus 2 root 3. It's like saying x plus 2x. Okay, let me start it the way you can easily understand it.
I understand.
What will it, okay, beautiful. What will it give you? If this was x plus 2x, what would have been the answer?
3x.
3x. So root 3 plus 2 root 3 will now be equal to, since x plus 2x is 3x, root 3 plus 2 root 3 will give you what?
3 root 3.
Beautiful, 3 root 3. You are fantastic. Okay, so let me give you an example, another one. Five root 2 minus 7 root 2. What will it give you? 5 root 2 minus 7 root 2.
Minus 2.
Awesome. Minus 2 root 2. Because if you had 5x minus 7x, it would have been minus 2x. Okay, now it keeps getting interesting. Look at C, because I'm going to take it further into something else. If you have 18, root 18 minus root 50. Okay, sorry. Root 8. Root 18 minus root 8. Can you solve this one? Root 18 minus root 8. It's just like saying x minus y. What's the value of x minus y? They are not like terms. They are not like terms, so it will still be x minus y, is it not?
Yes.
You cannot simplify root 18 minus root 8 like that you cannot get the answer like that until you simplify it. Root 18 minus root 8 is not root 10. No, you don't just say 18 minus 8. Do you know?
Yes.
Because they are not like terms. It's just like saying 18 oranges minus 8 bananas. Will you say 10 bananas?
No.
18 oranges minus 10 bananas, they are not related. So you have to simplify it in a way that all of them will not be the same. Then you can now collect like terms. Okay, so what do? Apply something I mentioned to you earlier. Sometime I told you that you try and reduce them so that it will be two factors, one is perfect square, one an ordinary number. 18 will be what? One of the factors has to be a perfect square.
3.
One of the factors must be a perfect square.
Yes. 3 root 2. It will be 3.
Excellent. 3 root 2. I know you are fantastic. I know you got it by saying root 9 times 2. Is it not?
Yes.
Because 18 itself is 9 times 2. 8 itself is 4 times 2, isn't it?
Yes. The 8.
8 itself is 4 times 2, or rather root 8 is 4 times 2, and eventually what you did was root 9 times 2 will give you root 9 times root 2, and root 9 itself is 3, so this is simply 3 root 2. So minus root 4 times root 2 is the same thing as root 4 times root 2, or simply 2 root 2. Because root 4 is 2, root 9 is 3. So now 3 root 2 minus 2 root 2 will give you what?
1 root 2.
Or simply root 2. So root 2 is the answer.
Yeah.
Is that cool enough?
Yeah.
All right, go ahead and simplify this question we want to look at now. Go back to the previous page. Question number 5. Let me zoom it in. Use the same principle. What I will do, I will just copy it and put where we see it better. Or just zoom out. Zoom out very well and solve it here. Root 98 minus root 50 over root 32. Root 98 minus root 50 over root 32. You can solve it on the left hand side or on the right hand side if you have enough space. Or do you want me to copy it so that you can put it? Okay. And that space is too small. Please let me take it to where we are. Just a moment. Let me take it to where we are so that you will solve and then get the answer. Go back to that page. Go back to page 12 now. I'm putting it on page 12. I'll make it big on page 12 so you can now solve. All right. I'll go ahead and solve. Root 98 minus root 50. Interesting. Okay. I love that. All right. Interesting, because 98 is 2 times 49, so root 98 will be root 49 times root 2. Root 49 itself is 7, so that's 7 root 2. Beautiful. So simplify the other one. You didn't do add maths in secondary school, did you?
Right?
Did you do add maths?
Add maths.
Yes.
Further maths.
Yes, further math, did you?
No, I did not.
Oh, okay. So that's 7 root 2 minus 5 root 2, because 50 is 25 times 2. So root 50 is root 25 times root 2, and root 25 itself is 5. So that's why it's 5 root 2. For 32, interesting. Okay, similarly, root 32 is root 16 times 2, and root 16 itself is 4. That's how you come about 4 root 2. Okay, now continue. Beautiful. Over. So 7 root 2 minus 5 root 2 will give you 2 root 2 over 4 root 2. Interesting. Root 2 cancels out root 2. Beautiful. So you have 2 over 4. It's cool. You see the trick in this thing. Lovely, lovely. That's 1 over 2. Okay, now we take it further. Yeah, so A is the option. You won't have a calculator to do the trick you did earlier, so you have to learn it the way you just learned it. Let's do something else. We call that, go to the next page. Rationalization. Rationalization of sword. Let's start with the simplest one. If you have something like 1 over root 2, once the sword is a denominator, you need to rationalize it. To rationalize it, you simply multiply it by that denominator up and down. 1 over root 2 is the same thing, and let me explain to you what I mean. It's the same thing as 1 over root 2 times root 2 over root 2. To rationalize a source is simply multiply it by that denominator or that sword in the denominator up and down. Okay, so 1 times root 2 will give you what? Root 2. Root 2 times root 2 will give you what? Yeah, I didn't mention that to you. When you are multiplying roots, just multiply out the numbers. This is what I mean. If you have root A times root B, it's simply root A times B or root AB. Do you understand?
Yeah.
So what is root 2 times root 2? Or root 2 times root 2?
Root 4.
Root 4. And what is root 4? So root 2 times root 2 is root 4, which is, root 4 is the same thing as 2, isn't it?
Yes.
So root 2 times root 2 is root 4, which is, square root of 4 is 2. So the answer is root 2 over 2. So when you ask to rationalize a sword, multiply it by that, a sword in the denominator up and down. Let me give another example. I'll call this one example A. Example B, if you're given 2 over 3 or 4 root 3. No, let me call it 3 over 4 root 3. Rationalize it. Do you know that you cannot divide this? What I've written, has it shown at your end?
Yes.
3 over 4 root 3. You can't divide 3 by root. You can't divide this 3 by 3 up here.
I know.
Did you say why?
I know.
Oh, you know that. Yes, you know. You can't divide this 3 by this 3 here because this 3 is inside the root. They are not related. Okay, so how will you rationalize this? Multiply up and down by only the root, the sword. So go ahead. You don't need the 4. If you use the 4, it's not wrong, but you don't need the 4 so that the answer will just be faster. You just use only the sword part, the root part. I've cleaned the 4. Go ahead. If you added the 4, no problem. It's just that it will make the work harder. That what you need is just the sword. So you multiply up and down by only the root part, by root 3 over root 3. And that will give you what? What is 3 times root 3? Root 3, exactly. Just like 3 times x is 3x. So 3 times root 3 will be 3 root 3, because 3 times x is 3x. Over what? Four root 9. Good. Because root 3 times root 3 will give you root 9. Can you simplify further?
Yeah.
Go ahead. You can write it below if there's not enough space there. Don't worry, you're trying. It's not easy too. I don't know how you're managing to write. It's not easy to write with your, and I'm using a stylus, so it's easier. I will talk to, I will try and make sure you get this stylus so that you can write better. I'll work on it. Please, can you just write it below so that, you know, you would have even started from here. So you just continue from here. So what does it give? Yeah, go ahead. Beautiful, because 4 root 9 is the same thing as saying 4 times root 9, and root 9 is 3. 4 times 3 is 12. So simplify. What does it give? Root 3 over 4, because 3 here 1 into here 4. So it's root 3 over 4. Interesting. Let's look at the last part of it, which is rationalization of using conjugate. Go to the next page. No, you've answered that. What do you want to write? No, that's the answer. It's root 3 over 4. That's the answer. Yeah, it is. And no, when we say you rationalize, yes, root 3 over 4 is it's like saying 1/4 of root 3. No, you see, when we rationalize a surd, we now make it a fraction. So root 3 over 4 is like, by the way, the point is this: when you are rationalizing a surd, you are trying to remove the root from the denominator. Go to the previous page. Yeah, you are trying to remove the root from the denominator. Like this first example where we started with 1 over root 2. By the time you rationalized, it became root 2 over 2. So the root is no longer in the denominator. And then when we also had 3 over 4 root 3, 3 over 4 root 3, when you finish, it became root 3 over 4. So once the root is no longer in the denominator, you've achieved the purpose. There's nothing else you can do again. Yeah. All right. Now, when it is in go to the next page. Now, let me show you where to use conjugates. If you have 2 over something like root 2 minus 3. Or root 2 plus 3 or whatever. The root is still in the denominator. So to rationalize it, you do not say, we cannot say times root 2 over root 2. Because there are 2 numbers in the denominator. 2 terms in the denominator. Do you understand?
Yeah.
So we cannot say times root 2 over root 2. But if this root was over everything, if it was over everything like this, did you see what I just wrote?
Yes.
If the root was over everything like this, you can actually say times root 2 minus 3 over root 2 minus 3. You can say that, but it's not over everything. So you can't say that the root is only on top of root 2 alone. So I've returned it to how it was before. Root 2 is only on top of root 2 alone, and so we cannot say, you can't say times root 2 over root 2. You are going to multiply it all the same, but you are using what we call conjugates. The conjugates are the same thing, but the sign in between will change. If it was minus, it will change to plus. If it was plus, it will change to minus. So you multiply it by, this is the original thing. Let me write the original thing first of all. The original thing was 2 over root 2 minus 3. So you are going to multiply it by, this time around you're multiplying it by 2 plus, root 2 plus 3. Over root 2 plus 3. Did you see what I wrote?
Yeah.
So you multiply it by root 2 plus 3 over root 2 plus 3. If it was a minus, just change it to plus. If it was a plus, just change it to minus. The number still stays the same. The original thing still stays the same. It's what you're multiplying it with that will change. Is that clear?
Yeah.
Now this thing you're multiplying it with is what we call its conjugate. It will rationalize it. In other words, it will remove the root from the denominator. Okay, so let's just walk through this one very quickly before I give you another one. If you're multiplying 2 by all of this, it's like saying 2 open a bracket root 2 plus 3. And then this, the denominator will also be root 2 minus 3 times root 2 plus 3. Let me be sure you understood what I wrote.
Yeah. Yes.
Good. 2 times all of this, that's 2 open a bracket, all of this, for the numerator. Root 2 minus 3, the first one, then root 2 plus 3, the second one. Do you remember difference of 2 squares in algebra?
Yeah.
Something like this. Let me remind you. You are fantastic. You're actually a very strong math student. You need to be really discovered. You are actually you have a very analytical mind. A squared minus B squared. If you remember,
A squared is A.
I am sure something is ringing in your mind. I'm sure you are getting it. You are remembering something. I'm sure you are remembering something, but I'll just help you to remember it. Should I help you to remember it? Looks like it's been a while you practiced that, but you are remembering. Pardon? Yeah, okay, like numbers. If I give you a number, like maybe say 5 squared minus 3 squared. Is that what you're talking about? Something like 5 squared minus 3 squared. Yeah, 5 squared minus 3 squared. First of all, what is 5 squared? 5 squared is 25, isn't it?
Yeah.
3 squared is 9. It's like saying 25 minus 9. I think that's 16. Am I right?
Yeah.
Okay, that's 16. Now, let me tell you the rule. You're going to apply that rule and verify this, what I just did. A squared minus b squared, somehow when you were answering, I just have a feeling that you are familiar with this. You probably just escaped your memory. A squared minus b squared, just pick out the a's, add them first of all in a bracket, and also subtract them first of all, and again in a bracket. So a squared minus b squared, it is a plus b into a minus b. You can write any one first, or a minus b times a plus b. Apply it here. Let's see if we will still get the same answer, 16. I think we would have written 5 plus 3, then times 5 minus 3. What is 5 plus 3?
5 plus 3, 8.
8 times 5 minus 2, 6. Yeah, and you still get 2. You still get 8 times 2 will still give you 16, which is the answer we got initially. Yeah, so 8 times 2 will still give you 16, which is the same thing we got initially. So the rule is valid. We call it difference of two squares. Okay? Now why I'm saying it is, this one under here, you don't have to bother yourself to expand. Just apply difference of two squares. For instance, if a plus b bracket a minus b will give you a squared minus b squared, that means this one, root 2 minus 3 bracket root 2 plus 3 will give us one of them squared minus the other one squared. So this will be, let me solve the denominator first. Applying difference of two squared will be root 2 squared minus 3 squared. Is that not what we said?
Yeah.
Okay, that's the denominator. Without even wasting out, because if you expand, you will get the same answer. A plus b, whether you start with a minus or you start with a plus. Once you have one in a plus and the other in a minus, it's simply one of them squared minus the other squared. So this that we have here now in a bracket, and then this we have here in another bracket, is simply one of them squared. The first one should be always start first. One of them squared minus the other squared. Minus must be in between the two for the final answer. Okay. Simplify the denominator. Simplify the denominator. Sorry, the numerator now. Yeah, numerator. Go ahead. 2 root 2. Beautiful. That's 2 root 2 is 2 times root 2 is 2 root 2. And then 2 times 3.
6.
6, okay, yeah. Alright, so we have 2 times root 2 is 2 root 2. 2 times 3 is 6, so 2 root 2 plus 6. So let's simplify this denominator, which will now give us the final answer. This is equal to 2 root 2 plus 6 over root 2 squared is 2. Do you know?
Root 2, yeah, root 2 squares.
Because the square root will cancel out the square. And 3 squared is what? I'm just telling you that this is the same thing as 2 minus
3 squares, 9.
9. So 2 minus 9 will give you minus 7, right?
Yes.
So minus 7, that's the answer. Okay, do this one, the next page. All right. Interesting. Beautiful. So, is it root 2, 2 root 3 over root 2 minus 1 is equal to 2 root 3 over root 2 minus 1 times root 2 plus 1 over root 2 plus 1, which are the conjugates. Okay? Okay, so you're applying the difference of two squares for this denominator. Let's go. Interesting. Which gives which one do you want to simplify first?
The lower one.
The denominator, all right. Let's go. Just apply difference of two squares for the denominator. Interesting. Minus 1, okay. Applying difference of two squared, that should be root 2 all squared minus 1 squared. Yeah. So simplify the numerator.
That
2 root 6, that's correct, because root 3 times root 2 is root 6, so that's 2 root 6 plus see, I'm seeing something you wrote. Did this write 2? That's 2 root 3 times 1.
also.
Okay. Two root 3 times 1, okay? That would just be simply 2 root 3. Good. By the way, this whole denominator will give what? I'm happy you. That's, I think, 2 minus 1.
2 minus 1, which is 1.
1. So you don't even need to write over, because over 1 is the same thing as the number. So it's only the numerator that we write. That's the answer. That's correct. That's the answer. 2 root 6 plus 2 root 3. That's just the answer. I'm really, really impressed with this performance. Just a moment. Assuming you had 2 root 2, you were to conjugate with 2 root 2 minus, say, let's say 3 root 2. I'm not going to do all that, just to remind you. If you had to conjugate with 3 root 2 minus 2, in other words, if you had something like this, root 2 over 3 root 2 minus 2, you're going to multiply it by, it's going to be this over 3 root 2 minus 2 times 3 root 2 plus 2 over 3 root, okay, let me even make this one plus. Okay, it's the same thing. If this is plus, let me just change it slightly. If this is plus, this is plus. So the conjugate will be minus, is it not?
Yes.
Minus 2. Minus 2. You multiply both up and down by the conjugate. So this one will give us 2 root 2.
I have a question.
Yes, go ahead.
Is it not possible for this one to cancel this one?
This one to cancel this one? Oh, lovely question. It cannot cancel it unless this one also has it. The other two also has it. So what I'm saying is, if this one had root 2, the root 2 up here can cancel all of them. See, anything that is cancelling must cancel all the terms. If all the terms don't have it, it cannot cancel. Did you hear me? So this root 2 cannot cancel this root 2. Reason being that this number here, the other term does not have root 2 for it to cancel. Is that clear? Okay, so the conjugate is 3 root 2 minus 2. 3 root 2 minus 2. And of course, this will give us, let me just multiply out. Root 2 times 3 root 2 will give us 3 times 2, which is 12, 6. 6 minus root 2 times this will give us 2 root 2. I just multiplied out. I just multiplied this by this. Can you verify?
Multiply.
I just multiplied this by this. I'm multiplying out this times this, which I've gotten as 6, and this times this, which I've gotten as 2 root 2. Can you verify? Because root 2 times root 2 will give us 2. Do you know?
Yeah. Yes. 2 times 3.
That's root 4, which is 2. And 2 times 3 is 6.
Yeah.
All right. So I just made it faster. Then all over, are you ready?
Yeah.
Okay. Applying the other rule again, this squared plus this squared. Do you know? This squared plus this squared, the same thing. Huh? So 3 root 2 all squared. Oh, sorry, minus. So minus 2 all squared. Difference of 2 squared, that's what I'm talking about. Do you understand?
Yeah.
3 root 2 all squared, then 2 all squared. So this will give us 6 minus 2 root 2 for the numerator, that's the numerator, divided by the denominator now. Can you give me the answer to this one? This first one.
3. The answer is 2.
You know?
Wait,
Yeah, please go ahead.
minus 1.
I'm talking about only this one. Just give me the answer to only this one. Open a bracket, 3 root 2 all squared. Do you know that it's the same thing as saying?
Yeah, I know the answer.
Okay.
The answer is
I'm listening.
no, I don't know.
Pardon?
I don't think I know the answer.
You know, 3 squared is 9, isn't it?
Please. Oh,
Each one will be squared. 3 squared is
the
9.
answer is 8. Oh, the answer is
18, yes, you're right. Because this will be 9 times 2. Because 3 squared is 9. Root 2 squared is root 4, which is 2. So in fact, this is like saying 3 squared times root 2 all squared. Then before I do 2 all squared. Because when you open the bracket, the square will affect each of them. 3 will be squared. Root 2 will also be squared. So 3 squared is 9. Root 2 squared is root 4. So 9 times, and root 4 is 2. 9 times 2 is 18. So 18 minus 4 is, I think it's 14, right?
18. Yes, 14.
So the final answer will just be, let me zoom out to write the final answer. The final answer will be 6 minus 2 root 2 over 14. Because this whole place is 18, this one is 4. 18 minus 4 is 14. So 6 minus, but you can simplify this one further. Let me explain to you how you can simplify it. I'm happy this came up because you asked a question earlier. Are you ready?
Yeah.
Can any number divide this, and also divide this? 2. Whatever you're going to use must divide all of them, all the terms. If you can divide all the terms, go ahead and do that. You can divide all the terms. So 2 into here, and into here.
And 2 into 6 is 3. Out to here
This
is
one.
1 and 2 here is 14.
So that this will just be 3 minus root 2 over 7.
Over 7.
Beautiful. I hope you know these two. You are not. You can't divide it divide the root 2.
Yeah, I know.
You know that. That's cool. All right. That's interesting. Just take note of the rules, whether you're applying conjugate or you're applying the other one. If you are rationalizing individual surds, just multiply it by itself, up and down. But if you are rationalizing something that requires conjugate, multiply by those conjugates. And apply your difference of 2 squares. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to 2 main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.